So we're going to start section 1.4, and in section 1.4, each of the problems ultimately involves factoring a problem that starts with three terms. We're factoring trinomials. But they're the hard kind of trinomials because the number in front of the squared term isn't a 1. So we're factoring trinomials with a lead coefficient. That's the number in front of the highest power term. That is not 1. In section 1.3, we factored trinomials whose lead coefficient was 1. And that actually is a little bit easier. And so this is the kind of problems we might get. We might be asked to factor something like 5x squared plus 14x plus 9. It's three terms, it's a trinomial, and in front of the square term, there isn't a 1. Similarly, maybe we might be asked to factor something like 6x squared plus 7x minus 10. Same kind of vibe to it. It's going to be a trinomial, and there isn't going to be a 1 or an implied 1 in front of the square term. For this kind of problem, there's at least 3 ways to teach how to factor this. I could maybe even think of a fourth real quickly. The methods that you can use is you can rewrite so that the problem has 4 terms. And then factor by grouping. You could use a method that I know that they teach at Mountain Ridge and Sandra Day called bottoms up. And you can do more or less factor in your head. And the factoring in your head, it's, I guess we might call that guess and check. Factoring in your head is probably the best way to factor, but it's not really realistic for most students in the course of one section to kind of master this strategy. If you can remember the method that you learned in high school and you remember how to use it, then you don't need to watch the video. If you can do the problems in this section without me explaining a new method, then do it. There's no need to learn a new method. If you kind of remember a method but not completely, and I don't cover that method in the video, you can send me a question and I can maybe make up a short video just to explain that method to you. Anyways, this is the method I'm going to teach in this section, specifically because it's super accurate. It's similar to something that we've done a couple times already, so I think it's maybe, if not the easiest to learn, it's easy-ish to learn, and it's a nice method in that there aren't like common mistakes that students make to make the method dangerous. I used to try to be consistent with the high schools around here and teach bottoms up. Bottoms up has a lot of steps. I guess maybe about the same number of steps. But the issue with bottoms up that I had is that students just never, well, most students got it perfectly, but a lot of students just never quite mastered the steps. They did stuff that they always forgot a step. So students from my perspective, because I taught this for 3 or 4 years, often forget a step and get the wrong answer, because you can't really tell that your answer is right if you don't check. And on top of it, if you use the bottom-up method, you get a wrong answer if there's a GCF and you forget to factor it out first. So I used to teach bottoms up. I'm not going to do it on this video, but if you remember liking bottoms up, shoot me an email and I can probably do a quick video of 3 or 4 problems that might help you remember how to do it. Factoring in your head, I love this method. That's the method that I use, but it takes more than an hour video to kind of get that perfected. So for all the problems in section 1.4, I'm going to use this method. You're absolutely welcome, if you know either one of these methods or a different method, if you could factor this problem or this problem without me explaining, more power to you. So if you looked at this and said, well, I know that this factors into, because I factor into my head, I know that this factors into 5x plus 9 times x plus 1, and either you could factor in your head or you could use bottoms up or some other method. If you're able to factor that without the video, then don't watch the video. Similarly, if you knew that this factored into 6x, let me do some factoring in my head, x 2 plus minus 5, if you knew that that second one I wrote down factored into that, then you don't need to learn a new strategy. But if you don't know how to factor these already, I'm just going to teach this one method. There are 3 groups of problems in this section. The first group specifically asks me to use this method. The second group asks me to use one of these 2 methods. And I'm going to wind up skipping that chunk of problems. I'm not going to teach this method. And then there's a third group of problems that we'll do. So there's going to be some problems that we skip in this section. So for problems 1 through 18 in section 1.4, I'm going to take a problem that has 3 terms. I'm going to write it with 4 terms, factor by grouping, and maybe check my answer. So for each one of these problems, when you have 3 terms and a number in front of the squared term, the first thing I'm going to do is I'm going to multiply the lead coefficient times the constant. So step 1 is to multiply the lead coefficient, in this case 5, times the constant. Always when I'm factoring trinomials, I'm looking for numbers that multiply to a number and add to a number. This is the number that I'm going to need to multiply for. So now I'm going to search for numbers that multiply to be 30 and they add to be 13. And I'm going to rewrite the 13x using those 2 numbers. So let me find my factors of 30. But real quickly, I need to know the signs. Because this problem is a plus plus, the signs of the factors are plus and plus. Again, this template here is still going to work. And then for my factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Let me write these down real quickly. The factors of 30 are 1 and 30. Those are the plus plus factors of 30. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. I need to add these now. I'm going to do 1 plus 30 and get 31. I'm going to do 2 plus 15 and get 17. I'm going to do 3 plus 10 and get 13. Don't really need to do the 5 plus 6 and get 11, but I could. This is the pair that I need because those are the plus plus numbers that multiply to 30 and add to 13. So what I'm going to do with the problem is the 13x that's in my problem, I'm going to break it up into 3x plus 10x, because 3x plus 10x is 13x. This will allow me to take the problem that starts with 3 terms and change it to 4 terms. And when I do this breaking up into 3x plus 10x, it doesn't really matter which order where I put the 3. I could make it first or I could make it second. Both of these would be correct ways to rewrite the problem, and it doesn't matter which you choose. Your algebra is going to look different if you choose a way different than me, but the answer is going to be the same kind of regardless. So I've broken it up into 4 terms, and now I'm going to introduce my 2 parentheses and factor by grouping. My first parenthesis is just a common factor of an x. I'm going to factor out the x, and I'll be left with a 5x plus 3. My second parenthesis is a common factor of a 2. That's the biggest number that divides evenly into 10 and 6. I'll factor out a 2, and I'll be left with another 5x plus 3. Now I can either write the common factor followed by what's in front of the common factors, or what's in front of the common factor in its own parentheses followed by the common factor. These are both correct answers, and I'll check one just to show you that it checks. They both would check the same way. I don't really have to check these, but it's never a bad idea. So if I want to multiply 5x plus 3 times x plus 2 to make sure my answer is correct, when I multiply it, it should equal the original problem. I'll start off, I'll do 5x times x, which is the first part of foiling. It's going to give me a 5x squared. And then 5x times 2, that's a positive 10x. And then 3 times x, that's a positive 3x. And then 3 times 2, that's a positive 6. You'll see that 10x and 3x come back up here. I know that those add up to 13x. So this is going to give me 5x squared plus 13x plus 6. So I can put a big check sign because that equals the original problem. Alright, so I'll just mow through and we'll do all the first 18 problems because we need to do at least 9 of these. So first step, when there's a number in front of the square term, is to multiply the lead coefficient times the constant. I'm going to get the same product here because I'm multiplying the same numbers 5 and 6 when I do number 4. I still get 30. And I'm still looking for numbers that multiply to 30. And they still have to add to the middle number. And that middle number is negative 13. But in this world, when the problem signs are minus and plus, I'm looking for the double minus numbers. So the numbers that are candidates to split negative 13x up are these numbers double negative, because negative 1 times negative 30 are double negative numbers, but they multiply to 30. Negative 2 times negative 15 are potentials, they're double negative and they multiply to 30. Negative 3 and negative 10, double negatives multiply to 30. Negative 5 and negative 6, double negative multiply to 30. Instead of adding each one of these, I'm just going to do the one that works. The negative 3 plus negative 10, if you add those, if you do negative 3 plus negative 10, those add to negative 13. That's the pair I'm going to need. The negative 2 and negative 15, it looks like there's a 13 there, but if you added those, negative 2 plus negative 15, those actually add to negative 17. That's not the pairs I need. So I'm going to use the numbers negative 3 and negative 10 to rewrite the negative 13x. I'm going to say negative 13x equals negative 3x plus negative 10x. And because plus a negative is the same as a minus, I'm going to really say, actually I'm going to say negative 13x equals that. And better, before I get into my problem, I'm going to say negative 13x equals negative 3x. And instead of writing plus a negative, I'm going to do minus 10x. I'm going to rewrite the problem with that minus 13x replaced with that. So I'm going to start off and do work that's actually needed now. So I'm going to go 5x squared minus 3x minus 10x plus 6. I wrote an equal sign because what I wrote equals the line above it. Now I'll do my grouping. First two terms go in their own parentheses. The negative sign goes in the parentheses with the second two terms. My first parentheses just has a common factor of x. When I factor out an x, I'll be left with a 5x minus 3. The second parentheses leads with a negative, so I need to factor out a negative. And between 10 and 6, there's a common factor of 2. Now I'm going to change the signs because I factored out a negative. I'm going to divide by 2 because I factored out a 2. So that negative sign is going to flip to positive. That 10 I'm going to divide by 2 and get a 5. I didn't factor out an x, so I'm going to leave the x with the 5. Because I factored out a negative, that positive sign is going to flip to negative. Because I factored out a 2, that 6 I'm going to divide by 2 and get 3. Now I'm ready to write my answer, and I could either write the common parentheses 5x minus 3 followed by what's in front of the common parentheses in its own parentheses, or I can write the common parentheses followed by, or I could write what's in front of the common parentheses in their own parentheses followed by the common parentheses. Let's do 5 together. Why don't you pause the video, try to do 5, and then I'll work it out. Again, if you know how to factor these problems using another method that's not rewriting with 4 terms and factoring by grouping, you don't have to use factoring by grouping. It's just a method that I think is easy to learn and it's accurate. So in problem 5, I'm going to start off by multiplying the lead coefficient 4 times the constant 3 and get a 12. So I'm going to search for numbers that multiply to 12, and they have to add to 7. And this is the easiest row of my template. The numbers need to be plus and plus. And in terms of numbers that multiply to 12, they're 1 and 12, 2 and 6 are 3 and 4. So my choices are 1 times 12, that's plus plus and multiplies to 12. 2 times 6, that's plus plus, it multiplies to 12. And 3 and 4, that's plus plus, it multiplies to 12. Hopefully you can quickly tell that the 3 and 4 are the pair that adds to 7. I'm not going to worry about the ones that don't work. So I'm going to take the 7x in the problem and rewrite it as 3x plus 4x. So I'm going to start my problem that had 3 terms, and I'm going to rewrite it with so that it has 4 terms, making the 7x into 3x plus 4x. And now I'm going to introduce my parentheses and factor by grouping. We'll leave the plus sign in front of that second parentheses and not put it in the second parentheses. In the first parentheses, both terms have an x. I'm going to factor out an x to the first power. From the 4x squared, it started with 2x's. I take 1 away, I'm left with a 4 and an x. The 3x had an x. I take the x away, I'm left with a 3. In the second parentheses, there isn't a common factor because the biggest number that divides evenly into 4 and 3 is 1. Both terms don't have an x. There really isn't a common factor that's not trivial. Because there isn't an obvious common factor, I'm just going to factor out a 1 because I need something in front of my parentheses. Now I'm basically done. I can write my answer, which is either going to be 4x plus 3 times x plus 1, or if you prefer, the x plus 1 times 4x plus 3. They're both equally good. If you're feeling good about this, maybe you can just pause the video and just do the rest of the odd problems that are on the screen and fast forward. If not, I'll start with number 8. With number 8, I'm going to multiply the lead coefficient 4 times the constant 3 and get 12. I need numbers that multiply to 12 and that add to negative 13. And in the world of my template, I need minus minuses. When the original problem has a minus and a plus like this does, it has a minus first and a plus second, I need minus minus factors. And 12 I know. 12 is minus 1 times minus 12, that's the minus minus numbers that multiply to 12. Minus 2 times minus 6, that's another set of minus minus numbers that multiply to 12. And minus 3 and minus 4, that's another set of minus minus numbers that add to 12, multiply to 12. The pair that I'm going to need are the minus 1 and the minus 12, because if you add minus 1 and minus 12, those add to the negative 13. So what I'm going to do is I'm going to rewrite the negative 13y as negative 1y plus negative 12y. And I don't like having plus and negative. That just is, I mean, I guess it's okay, but I like doing it this way. I'm going to make this minus 13y equals minus 1y minus 12y. That's just what I choose to do, and I'm be consistent with myself. So, and again, you could flip-flop this. It wouldn't be any less right if you wrote minus 12y minus 1y when you split the problem up into 4 terms. So I can write this as 4y squared, and then my choice, I'm going to do minus 1y minus 12y plus 3. I'm going to introduce my parentheses, keep the negative inside that second parenthesis so I could factor it out. First parentheses, there's a common factor of a y. From the first term that had a 4 and 2 y's, I could leave the 4, take one of the y's away, so I'm left with 1y. After the minus sign, I had a 1 and a y. I leave the 1, took the y away. Second parentheses, I have to factor out a negative because the first term is negative, and the biggest number that divides evenly into 3 and 12 is 3. I can't factor out a y because the 3 doesn't have a y. So I'm just going to factor out a minus and then a 3. When I factor out a minus, I need to change the signs. When I factor out a 3, I need to divide by 3. That minus sign is going to change to positive. 12 divided by 3 is 4. So the first term is going to be a positive 4y. This positive sign is going to flip to negative. That 3, when you divide it by 3, you get 1. Now I'm just going to write one answer, but there's 2 acceptable answers. I'm going to write 4y minus 1 times y minus 3 for my answer. Maybe we'll do 9 together, and I'll skip on 10. So I'm going to start, I'm going to multiply the lead coefficient of 2 times the constant of negative 7 and get negative 14. So I need numbers that multiply to negative 14, and I either can say quote unquote add, or I can say subtract, because they're really going to subtract to be the 5. And this is usually the third level of my template. So the factors that I'm finding have to be plus and minus. The big number is going to get the plus sign, the small number is going to get the minus sign. For the factors of 14, there's not many of them. There's 1 and 14, 7 and 2. So my choices here, big number plus, small number minus would be 14 and minus 1, because those multiply to minus 14. 7 and minus 2, those multiply to minus 14. And I'm looking for the pair, technically it's adding, but realistically it's subtracting. And so if I did 14 plus negative 1, I'm going to get 13, because adding a negative is the same as subtracting. And 7 plus negative 2, that's the same as 7 minus 2, which is 5. So for this style of problem, usually here I would have written just 14 minus 1, or thought of that, and thought of 7 minus 2, because adding a negative is the same as subtracting. Anyways, it doesn't matter what I'm thinking of, as long as I can get the right pairs. And what I'm going to do is I'm going to take the 5z and write it as, I like to write the negative first. I'm going to write it as negative 2z plus 7z, as opposed to 7z minus 2z. Both are acceptable ways to rewrite the 5z. I like putting the negative first. It makes my factoring easier. If I have a positive and a negative that I'm splitting the middle term up into, I always write the negative first. So I'm going to rewrite the middle term with a minus 2z and a plus 7z minus 7. If you wrote it this opposite way, then you'd have to factor out a negative, which I don't care to do. So introduce my parentheses. First two terms, I can definitely factor out a 2 because both terms have a 2. I can also factor out a z because both terms have a z. I'm going to divide the numbers by 2 and take a z away. I'll be left with z minus 1. After the plus sign inside the second parentheses, both terms have a 7. I'm going to factor out a 7 and be left with another z minus 1. And then I have flexibility for my answer. I can write 2z plus 7 times z minus 1, or I can write z minus 1 times 2z plus 7. You can check every time, maybe you should, but it takes time. I'm going to go ahead and check this one just to show you that I'm good. I'm going to check the 2z plus 7 times z minus 1. I'm going to start off multiplying 2z times z, and then 2z times minus 1, and then 7 times z, and 7 times minus 1. 2z times z is 2z squared. 2z times minus 1 is minus 2z. 7 times z is plus 7z. 7 times minus 1 is minus 7. I'm going to combine those, and I already know that those combine to be 5z. So this is going to be 2z squared plus 5z minus 7. And that's exactly the problem I started with, so I know my answers. Oh, you could run off the screen, sorry. I did the foiling here. 2z times z, 2z times negative 1, 7 times z, 7 times negative 1. The 2z times negative 1 and the 7 times z give me that pair of terms, so those give me the 5z. This matches originally the original perfectly. We'll move on to 12. In 12, this is a minus minus, so I need the plus minus when I'm splitting up the numbers. Small number gets the plus sign. So I start off, I multiply the lead coefficient of 2 times the constant of negative 7. I get negative 14. I'm looking for numbers that multiply to negative 14 and either quote-unquote add or subtract, if it helps me, because I'm really subtracting, to get negative 13. And for 14, I know the numbers, but small number plus, big number minus. So it's either going to be 1 and minus 14, because those multiply to minus 14, or it's going to be 2 and minus 7, those multiply to minus 14. Let me add these here. If I do 1 plus negative 14, that's really the same as 1 minus 14. If I did 1 plus negative 14, I get negative 13. If I did 1 minus 14, I get negative 13. This is why I say it's quote-unquote add, or it's really subtracting, because adding a negative is the same as subtracting. So I'm going to break up the negative 13z. I have my choice of doing positive 1z minus 14z, or I can do minus 14z plus 1z. I prefer, if I have a positive and negative, to do the negative first. So I'm going to rewrite this problem with 4 terms. I'm going to write the negative 14z first, the positive 1z second. Now I'm going to introduce my parentheses. First parentheses, there's a common factor of 2z that I can factor out. When I factor out the 2z, I'll be left with a z minus 7. I'm going to bring down the plus sign Second parentheses doesn't have a common factor. I'm going to factor out a 1 and be left with a z minus 7. Now I can write my answer. It's either going to be z minus 7 times 2z plus 1, or, if you prefer, 2z plus 1 times z minus 7. They're equally correct. Both would check. Getting kind of long, but I think I want to get through to the end of this page before we move on. Let's do 13 together. Pause the video and try 13 if you want. I'm going to start off. I'm going to multiply the 6 and 7, the lead coefficient times the constant. This is the first on my table, so I need pluses. I'm looking for plus numbers that multiply to 42 and add to 23. So I'm going to look at my factors of 42. My factors of 42 are there. Hopefully I have them all. They're 1 and 42. That multiplies out to be 42. 2 and 21, 3 and 14, and 6 and 7. So 2 times 21 is 42. 3 times 14 are double positive that multiplies to 42. And 6 and 7, double positive that multiplies to 42. I need to pair that when I add the numbers that I get 23, and that's the 2 and 21 pair. So I'm going to take the 23x in the problem and make it into 2x plus 21. Make it into 2x, or I make it 21x plus 2x. I could have made it 2x plus 21x, but I accidentally wrote the 21, so I'm just going to do this. But you certainly could make it 2x plus 21x. Both would be okay. Doesn't matter. So I'm going to make this 6x squared. I decided to do 21x first, 2x second, introduce my parentheses. First parentheses, 3 is the biggest number that divides evenly into 6 and 21, so I'll factor out a 3. They both have an x, I'll take the smaller exponent of x to the first. Now I'll divide 6 by 3 and get a 2. From the x squared, take 1x away and be left with an x. After the plus sign, I divide 21 by 3 and get a 7, and I took the x away. So that first parentheses has a 2x plus 7. Second parentheses, both terms don't have an x, so I can't factor out an x, and the common factor between 2 and 7 is 1. So I'm just going to factor out a 1 and be left with a 2x plus 7. So for my answer, I'm either going to write 3x plus 1 times 2x plus 7, or I'm going to write 2x plus 7 times 3x plus 1. How about one more, then I'll pause on the video. And let me do 16. You should do 15 and 17, but the video's getting long. So I'm going to start off, I'm going to multiply the lead coefficient of 5 times the constant of 7 and get 35. I need numbers that multiply to 35 and add to 12, and that's the pair right there, because 5 times 7 is 35, and 5 plus 7 is 12. So I'm going to make the 12x into 5x plus 7x. I'm going to rewrite this problem as 5x squared plus 5x plus 7x plus 7. Introduce my parentheses. First parentheses, I'm going to factor out a 5x and be left with an x plus 1. Second parentheses, I'm going to factor out a 7 and be left with x plus 1. And then I'll write my answer. Just because the video is long, I'm only going to write it one way. So I'm going to move on to a part 2. There might be a part 3 to this video depending how long part 2 goes. But I'm going to pause this now because we're pushing 35 minutes and that's definitely long enough.